What's up, guys? So we were discussing some general characteristics of projectile motion, and I told you that the projectile motion is symmetric about the highest point axis. The range is maximum for theta is equal to 45 degree, and the range is same for theta and 90 minus theta angles. In this lecture, I'll be telling you a very important calculation technique. Okay, in which let me define the problem. So suppose you throw a projectile at an angle of theta with initial velocity u, and at some general time t, the projectile is making an angle of beta with the horizontal. And suppose at this instant the velocity is u dash. How to find u dash if u, theta, beta are given? Suppose the question is that I threw a ball with 30 meter per second at an angle of 30 degree or 60 degree. What will be the velocity of the projectile when the angle is 30 degree? How will you find it? Okay, so there is a long way and there is a short way. The long way is that you you find the vertical component. The vertical component is u sine theta, and here the vertical component is u dash sine beta, and then you relate them using the kinematics equation. This is going to be very long. What is the easier way? So the easier way is like this. Here is the trick. We know that horizontal component of velocity in a projectile remains constant. This is what we know. We know that the horizontal component remains constant. Just think about it. The initial horizontal component will be u cos theta. Okay, when the projectile is at an angle of beta with the horizontal and its total velocity is u dash, initially it is u at an angle of theta, and finally we want to talk about u dash when the angle is beta. So clearly in this triangle the horizontal component will be u dash cos beta and vertical will be u dash sine beta. Here the horizontal is u cos theta, here u sine theta, and we know that the horizontal component does not change. So can I write that u cos theta is equal to u dash cos beta? This is the trick. So from here I get u dash is equal to u cos theta upon cos beta. Okay, so the final velocity when the angle is beta is u cos theta upon cos beta. Very important result. Okay, and very handy. We can also find the time. After what time the velocity become u dash. How to find that? What will be the vertical component? Final vertical component will be u dash sine theta, sine beta, sorry, u dash sine beta. Okay, so this will be u cos theta upon cos beta into sine beta. So u cos theta tan beta. The initial vertical component is u sine theta. So let's use the equation of trajectory. Sorry, kinematics equation. So Vy is equal to Uy plus 80 Ayt. So u cos theta tan beta is equal to u sin theta minus g into t. So from here t is equal to u sin theta minus u cos theta tan beta upon g. So you can also find the time after which the projectile have makes an angle of beta with the horizontal. Okay, very simple. Let me just tell you one more property. It's not a property, it's obvious to you, but let me just keep this in your mind, that in projectile motion, velocity is never zero. Minimum possible velocity is u cos theta, and this occurs at the highest point. This is pretty obvious. If you are throwing a projectile, we know that the horizontal component will always remains constant, u cos theta. The vertical component keeps on changing. As the projectile goes up, the vertical component keeps on decreasing due to the effect of acceleration due to gravity. But what at the highest point? At the highest point, the vertical component is zero, but the projectile is still moving forward. And this is due to the horizontal component of velocity, which does not change. And this horizontal component is only moving the projectile in the forward direction. If this would have been zero, then the projectile would have fallen vertically like this, but it does not fall. It completes the remaining symmetric half of the trajectory. This is happening because this initial horizontal component is still there and it drags the ball in the forward direction. So the minimum velocity is u cos theta, and this is occurring at the highest point. Okay, so these are the some general properties of projectile motion. And if I have missed anything, please write in the comment section. Subscribe, like, add your comments. If there is another topic you want me to make the video, please let me know. Okay, so let's meet in the next video lecture. Thank you and stay tuned. Bye bye. Take care.